Hello everybody, and welcome to the Green Your Home zone of Zero Carbon Guildford. My name is Gordon Farquharson. I'm a volunteer with Zero Carbon Guildford, and I've been a local resident of Guildford since 1985, and professionally I'm a chartered environmental and building services engineer. And I was looking back at some of my educational past and reviewed my 1973 BSc thesis on a solar heated house. So I guess sustainability and low energy are in my genes somewhere. So this is first of a series of presentations, and we're calling it a route map to net zero. And this is intended as an introduction and sets the scene for further presentations related to specific actions that we might take in order to reach the goal. So my agenda in this presentation is to start off by making sure we understand what the principle of net zero means. Whose problem is it anyway? Is it ours? Is it a government? Is it going to be supported by subsidies? We need to understand how we might address the timing and the funding. What targets and deadlines exist? And I'm sure many of us are battling with what I call the technology minefield, with various suppliers inundating us with proposals for solar panels, heat pumps or other equipment. So we thought it would be really useful to try and develop a route map for addressing your existing premises, home, apartment, house, whatever it might be, and go through a logical approach. We'll talk about carbon footprinting and decisions that you might need to make and developing an action plan. We'll also look at some low energy initiatives and try and start to understand some of the challenges we have in our housing stock by looking at energy consumption comparisons. The meaning of net zero. Well, it's all about carbon reduction emissions. And I've taken some definitions that I've picked out from government references. And zero refers to achieving an overall balance between emissions produced and emissions taken out of the atmosphere. In a net zero scenario, the residual emissions from some sectors and some of our activities are allowed as long as they are offset by removing emissions using natural or engineered sinks. Whose problem is it anyway? Well, I think that the Surrey Climate Commission has a really useful summary in its report. The Commission produced a report in April 2021, and it clearly identified our role in this process. And there are a few interesting graphics. So I really like the iceberg graphic here, and it starts off at the top looking at high-level government and international targets, and then hidden under the waterline are a whole lot of things that need to be in place in order to deliver these high-level objectives. And these range from our personal behaviour through to things like building regulations in our country, government spending policy, and so on. So it's this hidden part that contains things that we need to act on. Maybe the declarations are just the easy part. The Surrey Climate Commission summary is really useful, and they produce some infographics that are here for sharing. Now, of course, this is focused on Surrey, and a lot of the data, particularly the carbon figures, were produced by the University of Surrey. And this is worth looking at just to understand the meaning. So there are two elements of carbon emissions that this graphic illustrates. First of all, consumption-based emissions, and secondly, direct emissions. So consumption-based emissions are the ones that are much more difficult to measure specifically, but they represent a huge amount, probably more than half of the carbon dioxide emissions in the county. And it covers all sorts of things like food, goods we consume, clothes, mining, construction, government services, aviation, shipping, and so on. The direct emissions comprise those things that we have a bit more control on. So travel, dominated by car travel, but not forgetting light and heavy goods vehicles. Housing, particularly important, and heating our homes represents a very large percentage of the direct emissions. And then industry, commerce, public buildings and so on are all important contributors. So in my route map, I will really be focusing on some aspects of the consumption-based emissions and the direct emissions. So what about some of the 2050 milestones that have been published? So here in the UK, the 6th carbon budget from April 2021 promised or set a goal to cut CO2 emissions by 78% compared to the 1990 levels by 2035 and to achieve net zero by 2050. Internal combustion engine car ban. So this is for new purchases. So 27 million cars are responsible for 56 million tonnes of CO2 per annum. In 2030, the sale of new internal combustion engine vehicles, cars, will be disallowed, prevented. It doesn't, of course, mean that second-hand vehicles will not be able to be traded. And 2035, hybrid vehicles, that's largely petrol-electric hybrids, will also not be allowed to be sold. Of course, in parallel with this, we have escalating fuel cost, which may well push us more rapidly in certain directions, particularly towards lower carbon personal transport. What about boilers for space heating? So by 2050 there are 28 million homes that will need to be converted to a low carbon source. They're responsible for 58 million tonnes of CO2 per annum. So by 2035, all new installations will have to be low carbon. And this is not fully characterised, but that is a principle. No new homes may be connected to gas from 2025. But it's unclear when the gas service will be discontinued or whether it will be continued supplemented by a combination of hydrogen and methane coming down the pipes to our homes. Of course, not in the plans were things around energy price escalation for gas and electricity and the impact of that. So the drive to low zero carbon is based on electricity versus fossil fuels. So the UK drive to net zero is predicated. The UK drive to net zero is predicated on the electricity grid getting to net zero in time. That's 2050. I quite like to look at what's happening out there, and if you're interested, have a look at this website, GridWatch, in which you can see in real time what is happening in the UK. And I'll just look at a couple of bits of this because you might be interested. So, first of all, we have some information about the power demand. So at any moment in time, you can see how much power in gigawatts is being delivered by our national grid, and the frequency of that, 50 hertz, which is a statutory obligation to deliver power at that frequency. If we look further at this graphic, we can see the power supply, the sources of power to satisfy that demand. And on this particular day, well, the percentages I always think are interesting, combined cycle gas generation was 41% of the demand was satisfied by combined cycle gas. And this is why there is such a strong link between gas pricing and electrical energy in the market. Nuclear was 17.8%, wind about the same percentage, nearly 18%, and then we had a small amount of pumped hydro, non-recoverable hydro. It was a dark, cloudy day, so the solar was negligible, and we had 8% of biomass, no coal, and no open cycle gas generation. And then this I always find fascinating. We have a number of interconnectors. 1, 2, 3, 4, 5, 6 of them. And we were getting 5% of our power from France, 2.28% from the Netherlands, and we were sending some to Ireland and so on. So you can see the consumption of electrical power and our sources, and this will changes in real time. So carbon dioxide reduction has a number of additional benefits. So energy reduction generally equals a cost saving. Emissions reduction also will lead to improved air quality. That's both indoor and outdoor. And if you want to look at more to do with indoor air quality, then I suggest you look at some of the work being done by Professor Prashant Kumar from Surrey University's Global Centre for Clean Air Research. Right, there's so much out there. Where on earth do we begin? It's a bit of a minefield. Do we focus on draft proofing? Solar PV, I'm sure some of you have seen The Salesman. What about insulation? Insulate, fabric first. Maybe you can resolve things by choosing an energy supplier. Solar thermal, often forgotten, but a very important consideration, particularly for domestic hot water use. Solar PV linked to battery storage. This is being pushed by many suppliers. Vehicle to grid or vehicle to load. Another important aspect. Ground source heat pumps. Radiant panel heating. The re-emergence of sophisticated electrical storage heaters. And of course, air-sourced heat pumps, which are held up by many to be the holy grail. So there's a lot out there. How do I decide what to do? So we think it's a journey, and you need to go have a clear mind and go through a sensible course of thinking and evaluation before you dip your hands into your wallet and spend money in maybe a fragmented way. So let's look at the journey. We reckon assessing your carbon footprint is an important first stage. Identify the priorities, and we suggest that you use the carbon footprint for home, largely heating related, transport, and some lifestyle consumption considerations. Evaluate the solutions and the options on the table. Make a plan. Finalize those plans and then implement them. For example, it's very unlikely that it would be sensible to throw away your gas boiler tomorrow morning, but maybe you need to have a plan for what to do in the event that it fails. So in the property, we need to consider the fabric of the building. So that's looking at drafts and thermal insulation. We can then consider technological solutions, whether that's photovoltaic and batteries, solar thermal, changing to heat pumps, and so on and so forth. In transport, certainly Guildford Borough Council is promoting personal active transport. We see the emergence of some electric zero tailpipe emission buses. Maybe the pensioners of Guildford Borough will be seen whizzing up and down to the high street on scooters in the future, provided they behave properly. Electric vehicles and integrating those with other energy sources for effective and efficient charging will also be important considerations. Lifestyle, the food we eat, the quantities, the sources, clothing and fashion. Waste, a major issue still, how we deal with waste. And packaging, huge opportunities to reduce the carbon embedded in packaging and of course the reprocessing of it. So carbon footprinting, this slide just quickly has two references which you might find useful if you want to investigate your carbon footprint. You need to do a bit of preparation before embarking on carbon footprinting. So do some homework, particularly energy consumption figures from bills or smart meter data ideally. Sort out any extraordinary events to note that may have distorted your normal consumption model. Most of the footprinting software categorizes your carbon footprint into these sort of areas, so ranging from household energy consumption, your international or flying transport, personal transport, public transport and so on, right down into some aspects of banking, education and recreation. Understand your situation, circumstances and aims. What kind of property do you live in, and what are the features, the fabric, the age and construction? What scope is there to improve? What is the configuration? Is it an apartment or flat, terraced, semi-detached house? Heating systems. Have some information about your heating systems, so what they can achieve, the heat output from the primary heating source, and the arrangement of the systems and controls. And we'll look at this in more detail in later presentations. What do you want to achieve? This might be really different. You might be planning to move soon and do not wish to invest and leave it to the next owner. Or you might be focused on a short-term energy reduction, a quick win to save money, carbon or both. Or you might want to improve the sale or estate value of your asset. And of course there's always affordability, how to fund the improvements and the timelines. Seems very clear to me that going green, reducing our carbon, is not going to be free of charge. And although there may be grants available in some areas, it's going to be necessary for us as individuals or society to spend money to invest in this reduction. So let's look at some housing energy benchmarks. I thought you might find this comparison useful. So if we start off with a typical UK housing stock, and it's very important to realise that by the time 2050 comes, 80% of the houses we've got around us will probably still be there. And how they're going to become net zero is probably the challenging matter. So it's quite difficult to establish definitive values of energy consumption, but I researched on the internet and found some university research material that identified that heat demand for a typical UK house was 170 kilowatt hours, that's units of energy, per square metre of floor area per year. So there's a typical value. In this comparison, you'll just be interested to see the magnitude of difference between different building styles. Air tightness, UK building regulations, shortly to be updated, middle of 2022, but we would expect to see buildings to have between 5 and 15 air changes per hour, that's exchange of internal air with air outside, through natural ventilation and building leakage. And this is pretty uncontrolled ventilation in many cases. If we were to then compare this with a low energy retrofit, and here I've taken a model from a program called Enerfit, and here the target would be to re-engineer, improve, upgrade the premises such that the heat demand goes right down to 25 kilowatt hours per square metre year. So 170 down to 25. If you get down to these values, then suddenly energy sources and the cost of driving them becomes a much less significant burden. The air tightness improves to 1 air change per hour, probably using mechanical ventilation and heat recovery rather than natural ventilation, which is somewhat uncontrolled. And then if we were to move to a low energy house, so I'm taking here an example of a 2020 passive house specification, so this is derived from a a German model but is now deployed internationally. And now the heat demand throughout for a full year for space heating drops to 15 kilowatt hours per square metre year, and the air tightness is less again, and in the winter you rely on mechanical ventilation and heat recovery. Now, of course, passive house design also requires very careful attention to summer conditions to avoid overheating. So that was a comparison of our current housing stock and perhaps how new builds should be today. Now, in a retrofit improvement, we really need to consider fabric first approach. And this is good practice even if we're just looking at reducing the energy consumption of our existing premises. So the fabric first approach tries to address where most of the energy goes, and this little graphic just indicates that air leakage could be 15 to 25% of the energy that is lost from the building. Leakage through the ceiling and roof, 25 to 35%, walls 15 to 25%, windows 10 to 20%, and floor 10 to 20%. Now, depending on your property, these are relatively more difficult or easier to achieve. So improving the insulation of walls might include cavity wall insulation, but if you have solid walls, 9-inch or 225mm brickwork, then wall insulation is much more challenging. Improvement of windows has a smaller energy reduction, but of course is generally easier to achieve. And floor insulation, if you have a suspended floor in a Victorian property, for example, we can improve the insulation there relatively easily. But if it's a solid concrete floor without good insulation under, any major improvement to that is highly disruptive. In a house built today to current UK building regs, it is necessary for the house to be leak tested. And this diagram just indicates the leakage paths that might exist, and this is how the test is carried out. So a dummy door is placed on the property, it has a fan in it, and you suck out air and you measure the amount of air that leaks in by measuring the amount that is drawn out by the extract fan. And there is a pass-fail level depending on the size of the property and so on. You could of course apply this to your existing home after you've done some upgrading. The next thing, which we'll look at in much more detail in a later presentation, is getting control of your existing heating system. So perhaps number one is make sure that your boiler flow temperature and hot water temperature are set optimally, 60 degrees centigrade instead of higher temperatures. Locate thermostat in a sensible location. Consider zonal control, so manually or using some modern sophisticated systems, have different temperatures in different rooms and control them, either manually or automatically. And importantly, monitor your consumption. About heat pumps, so particularly air-sourced heat pumps, are they a magic solution? Well, no, not on their own, and they need to be considered very carefully, and we'll look at that again in much more detail when we consider low carbon heating sources. But if I change from a gas-fired boiler, burning stuff, to an air source heat pump, and ultimately the electricity is net zero carbon, then I have a net zero heating system in my home. But it's not magic. It is an alternative to the boiler. It's likely to be much more expensive to run than current gas, even at escalating prices, if you don't fix the heat losses. It might not be a suitable or possible solution in your home. You may not have a convenient location for the air source component. Noise levels are an important consideration, for example. You are likely to require larger radiators in an existing legacy heating system. Maybe twice the area or more, because the flow and return temperatures are much lower. So to wrap up this session, we all have a role to play in dealing with climate change. There are unlikely to be easy solutions with someone else footing the bill. There will be some grants available which we need to take advantage of. We think a good starting point is to understand your carbon footprint, make a plan, get good advice, prioritise and implement it. Measure the progress you're making and share your experience. And one of the things that we're aiming to do from Zero Carbon Guildford's perspective is to provide information on likely possible solutions and also to feedback with case studies. So keep in touch, support what we're doing, and I do hope you found this route map introduction useful. Events we have to follow are in February, existing gas legacy systems to improve energy efficiency of those, and in March to look at low carbon heat sources, and in April we're planning to have a good look at smart meters and smart heating control systems and see if they're all they're cracked up to be. So thanks very much for your attention, and see you at another Zero Carbon event. Bye for now.